Splendor is a very famous board game. In this project, our group designed three different AI autonomous agents, namely A-star heuristic search, Q-learning, and Monte Carlo search tree that can play and compete in the Splendor game. Let us introduce them one by one.
The A-star search algorithm combines the advantages of both the best first search and the uniform cost search. Also, the A-star algorithm usually has better performance due to the bootstrap of the heuristic function. First, we determine the score that the current agent has obtained. If we do not gain a score, it will return the value by calculating the distance to the closest card. Also, we choose the goal state based on scores. If the score is increased or we already get 15 points, we will return true. If we have more times on it, we will detect the state of board and condition of opponent. In this game, Agent 0 uses the A-star algorithm. First of all, we can see that the A-star algorithm selectively takes strings at the beginning according to the string requirements of the corresponding cards. The goal of A-star in this state is to select cards in priority, regardless of whether the card has a score or not. After taking a certain number of cards, the strategy of the A-star's algorithm becomes clear. Take the novel. We can see that in last three rounds of the game, the A-star algorithm takes three nobles in consecutive rounds and finally wins.
When it comes to our second agent implemented by the Q-learning, the working principle of the Q-learning agent is basically a simple weight iteration update, and the Q value for each state is calculated by a linear combination of features and their weights. For the reward of each action at each state, basically we set the reward to encourage our agent to buy more cards, which color is more helpful to the agent to get the Nobel card. As for the feature selection, we mainly select 8 features showing as follows. However, for the challenge we have made, human bias is always on setting the reward and features. Also, the huge amount of training time is also a top problem we met. As for the future improvement, maybe we can have more training time to find the converge weight values and design more features to better describe each state in the game. At the beginning of the game, our agent would check which color are helpful to get the Nobel card so that our collect dream strategy is aimed to get the card with these colors. Also, we would aim to buy cards with a lower dream cost. Basically, most of cards we bought are from Tier 1 and Tier 2. As we can see, based on this strategy, we can easily to get our first Nobel card. Afterwards, we are trying to get more. And we also focus on the card with score since we already have many cards in hand, and these cards can help us to get the score and Nobel cards. When the card with the color is no longer needed for getting the Nobels, we will stop collecting the card with these colors. As we can see, based on this strategy, when a certain number of cards with desired color are collected, we can easily to get all the Nobels on the dealt to win the game.
Let's move on to mental color tree search. First, we use epsilon greedy when selecting nodes to handle the trade-off between exploration and exploitation, and use average return to update the node's value. As for rewards, in addition to the points got at each step, we also added more rewards. If the agent buys a card with 0 points but can help get noble, then it will also be rewarded. In this way, we hope it can learn more and better understand which action is best. The biggest challenge is how to access enough reasonable actions with a 1-second time limit. To achieve this, we limit the simulation depth to 3 to expand more nodes and prevent unreasonable actions to reduce branching factors. Besides, the agent also performs a code-based simulation, which is more realistic than randomly choosing. Another challenge is the rewards I just talked about. As for further improvements, we can apply other non-random simulation like heuristic, and we can also take our opponents into consideration, like detecting and preventing our opponents from winning. I will demonstrate the mental color tree search against A-star. Agent 0 is mental color tree search and Agent 1 is A-star. MCT agent is smarter than A-star. It always chooses the action with the highest Q value based on the rewards it learned from simulations, while A-star takes actions based on a designed goal strategy. In this case, its goal is to get noble in shortest path, and doesn't consider the point of the card itself, so it may miss better solutions. As a result, MCT outperforms A-star. And this is the end of our presentation. Thank you.